GM, tac, tac, tac. Uh, need- Is it the right link? Yeah, it's the right link. Let me just put a message. Pop, 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 pop. Um, two, two. All right. Just put the message. Um, Stack, stack, stack. Bladiba, bladiba. She's not here yet. She will jump soon. I just sent a message. If no reply in 2 minutes, I will call her. All right. Um, how everything is going. Let me check. Disk, Google Classroom. So. Okay. Okay. Alors, 34 people completed the assignment, so you have until tomorrow. No, today, tonight. Um, yeah, you have until tonight to finish it. Um, just Radiba, she's here right now. So we're gonna start. All right, all right. Yesterday was super blast. Like we didn't expected that on Zoom uh, no one can enter anymore because the room was full. And so yeah, people are just super motivated. So that's pretty cool. Let's see today if I have to upgrade the Zoom plan because actually I have like a Zoom plan for 100 people. But probably I will have to increase this one from 100 to 500. So let's see today how everything is going. You are still welcome if you want to jump into the session, but it's like 6 hour more. like 10 p.m. UTC, so it's super late. Hello, hello, Pratibha, could you hear us up? Okay, she's coming back, I guess. Tuk, 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 tuk. Okay, so all good. You can start. So for the context, by the way, Pratibha is one of our fellow, and she's right now leading the session. So it's pretty cool to see that from fellow to teacher. Let's go.
Thank you so much, Solin, for that. So yeah, I'm really happy to be a fellow in DevPack, and to those who are DevPack fellows, for me, it's really a wonderful space to be there, and you really learn a lot. So for today, we'll be speaking about the LISC summer bootcamp, and I'll be handling. Okay, let me share my screen first. Yeah, hope you can see my screen. Okay. Yeah. So today we'll be handling the LISC Summer Bootcamp, and the topic is connecting smart contracts to front end. And I understand you did cover up how to make a front end website, and you also covered up how to deploy a smart contract, and also how to handle errors in a smart contracts, and those other sessions that you've been having at vacation, etc. So with this, I'm Bratipa, as Selena has just introduced me. I'm a Web3 developer since 2021, and I'm also a Lisk ambassador, DevRel at Lisk. If you want to contact me, you can find me on Twitter at those handles, and also at LinkedIn. Yeah, so today, as I've said, you're going to discuss about decentralized applications and how to connect the smart contracts to front end. So definitely, we are going to start up with dApps and understand what dApps are. And for this whole session, I'll be just focusing on Lisk. But as we move on, or as we see how it interacts, because Lisk is also built on top of Ethereum. It's more of the same, but we are going to discuss about the Lisk ecosystem and how you can connect your particular front ends to the Lisk ecosystem chain. So, what does ADAP look like in the Lisk ecosystem? So, ADAP is a decentralized application, and apps never change, irrespective of which chain that you are in. So, they are basically applications that operate without a central authority and without a single point of failure. So definitely there are dApps that have already been built on Lisk, and yours, if one day you create a dApp, hopefully that yours can be or will be listed in one of the dApps that will be built under the Lisk ecosystem. So in the Lisk ecosystem, they're definitely divided into so many. I've only highlighted like the four, but there are so many. There's the decentralized finance, which most people call it DeFi. So this spans around lending, borrowing, and trading without banks. And some of the DeFi apps that you'll find in the ecosystem are like Uniswap, Aave, Oku.trade. This is very popular in Lisk, especially if you want to swap or bridge any token under Lisk, and also Velendrom. We also have another track called Real World Asset, and this is basically span around the tokenization of assets. So you could be tokenizing a land, you could be tokenizing a property, and some of the dApps that have been built on Lisk is like Backed and Noma Chain, whereby Noma Chain is a dApp that they are tokenizing real estate in Africa. Yeah, and then we also have NFT marketplaces, whereby here, for those who are quite conversant with the art world, you can buy and sell and mint unique digital assets. So in these particular marketplaces, you can either go and buy that particular art digital asset. You can go and upload your particular art asset so that you'll be getting a percentage out of those art that could be sold to other people. And this you can do with marketplaces like OpenSea, Blur, and Rarible. So in under the Lisk ecosystem, you can do it with OpenSea or Rarible, but Rarible is the most common one. With last year, I think
Ooh, oops. She's coming back. Oh no. Oh, yes. Sorry.
yeah. So the other games that are
Uh,
being played by other
so,
Web two side.
Atla,
Yes,
we missed
yes.
probably like the two last minutes because of your connection, I guess. And
Oh,
also,
oh my God.
question,
Okay.
could you upload the slide after in the class Google Classroom?
Yes, yes, sure, sure. I'll upload all the slides in the Google Classroom after this.
All right.
Okay. Yeah, yeah. So you'll be able like to follow up and find any information that in case I get lost again, please let me know because on my side I'm just using one device. Yeah, currently. Yeah, so the other track side, oh, we're talking about gaming. So we have Axie, Infinity, Decentralized, and Pokecoin, which is that is built on Leaks. The Pokecoin one is for the Pokemon cards. That if you want to go and try and find or own a particular Pokemon card that has been termed extinct or is close to being extinct, you can do that using Pokecoin. The other side is supply chain management, whereby here we have the transparent and trackable logistics. It could be under any particular category of building. Could be agriculture, could be supply and chain, could be I don't know anything that has supply and chain. So in Lisk ecosystem, we have Africabal, which they are concentrated on the agricultural side, whereby they handle all the logistics under agriculture from farmers to buyers and being able to remove the middleman or the central authority that's very common in the agricultural side. Yeah, so that's it in the dApps. So the characteristics of dApps, I understand Vicky should cover this, so I'm just going to roughly move on very fast on this. And if you need any more information on the dApps that are built on Lisk, you can also go and find them here on the Lisk portal under the ecosystem. Yeah. So all these links you'll find them on the slides. I'm just showing you. And yeah, there are so many categories infra with people like that web. There's also payments with people like Paycrest. There's also decentralized exchanges, centralized exchanges. We have Circle, and all of them are here. We have tools for aggregation of tokens like DeFi Llama, and yeah, you can just go check them out here. And if anything is making fun to you or is fun to you, you can just go and interact with them using the links that are there. So also with Lisk, if you want to get some LSK in trying to understand the ecosystem, there's
Quick question. Sorry. Are you sharing your screen or not?
yes, I am.
Ah,
Oh,
because
it's blank.
we can see it.
Oh my god, yeah, just got lost. Okay, yeah. Okay, now you can see my screen.
Yes.
Okay. So Lisk currently is doing season 2 airdrop, and the airdrop is structured whereby people who integrate with these particular startups can be able to get some LSK. So you can just go through this link. Yeah, let me just put it on the chat because I've not added it on the slides. Okay, so also let me drop just a link of the slides here so that we can go together. Yeah, so on the Lisk Alliance Boost, you can find almost like most of the or the most used dApps that are used in the ecosystem, in the Lisk ecosystem, to be able to understand. So they have different LSK awards for you to be able to be allocated to the people who create impact. So these are the people who are going to interact with the ecosystem. And yeah, so it spans out in the Africa side. There's Swiped for payments, Payd, and Power Pals, and Popcoin, and PhoneBank. And then the global side, there's Beefy, Gearbox, Mofo for lending and borrowing, and Melu, and then Velendro for liquidity. Yeah, so you can just go check out and try to interact with it, because I always think it's fun to interact with it. Yeah. Okay, let's move on. So the characteristics of a dApp is, as we'd spoken before with the Vikish, is first, it's decentralized, meaning there is no single entity of full control, and meaning that there is also no centralized servers. It's also open source, meaning all these projects that I've just mentioned or shown you, it's transparent, that you can see their code. You can be able to inspect their particular ecosystem and understand what goes on. There is also a technical white paper, and also you can understand their growth, even using with tools like the Llama, whereby you can see the particular liquidity that's moving across these particular dApps. There is also interoperability, with some of the dApps being able to borrow from each and every dApp company. So, for example, you could find like with Noma Chain, because they're dealing with the tokenization of real estates. At one point, they might need to create a liquidity pool for, let's say, one real estate company, so that they can manage that real estate. They could also use another dApp like Mofo, whereby if at all they're trying to lend the people who are trying to own a real estate property. And with this, once the interoperability comes to whereby this particular dApp can be used in other chains, and it can also integrate the particular features using other dApps within the ecosystem that they've built in. Another thing is dApps also, they have a cryptographic security, whereby this is done by the use of hashing and consensus mechanisms. I think you discussed about the consensus mechanisms before, and I think this is just like, it's clear the way it is, because this is how even the blockchain ecosystem is built. Another thing is tokenized incentives, whereby many dApps might have their own token, not each and every one. And this, sometimes some of the dApps also have incentivize their users using the particular token. So with the current season 2 airdrop of Lisk, you've just seen the incentivizing users if they use those particular dApps using the LSK token. And also, even with those dApps like Morpho, Velendrum, they also have different tokens that you could be incentivized for, either staking or providing liquidity, or just interacting with the particular dApp. Yeah, so that's it. I hope, is there any question concerning a dApp? What's the difference between dApps for Africa versus global? Okay, so I think that's just a question of the structure of that company. So you find some dApps, they've built for the market that belongs for Africa, but some dApps they built without targeting a market or a target market that's, let's say, it's all global. Like they don't care where the users are coming. But because most of the startups, maybe when they start and they're so young, they just concentrate on one particular type of market. But as they grow and as they grow their yield and as they grow their liquidity, then they proceed to move to global. Yeah. Okay. That's it. I don't think there's any other question. Yeah, so you might be wondering how are these particular dApps made? Yeah, and definitely, as you can see, if you just press one of them. Okay, let's see. We can do Jamit. So Jamit is like a TikTok. It's like the version of TikTok, but TikTok, no, Spotify. Spotify is the real one. So it's like Spotify, but a decentralized kind of Spotify, whereby you can. It has podcast, it has music, so whereby you can listen to music through um, blockchain. You can also host your podcast, and people can also say compete on whatever songs that I've been listening through using Quest and Leaderboard. So they also have that characteristics of token incentivization, but on the base layer, Jamit is just like your Spotify kind of app, but it just has like a decentralized mechanism or consensus mechanism. Yeah. So as you can see here, we definitely have a front end like any other website that you could see. But as you try to log in, let's just try it. Hope it's fast. So as you can see, just create your particular account using your particular email, and then now I'll have to have my email. Yeah. And then when you connect your email, it just gives you a verification code, and then from there on, then you can be able to interact with the particular Jamit site. So this is called account abstraction. I don't know if you talked about this. And this is whereby instead of users always going to blockchain made apps, instead of them connecting their wallet, you just abstract that logging in or that connection of wallet using either social signing in, email signing in, or phone number signing in. So this is meant for the users who are not quite conversant with the blockchain network to be able even to use these dApps while they don't have a knowledge that it's blockchain powered. Yeah. So you can go check out. We have it's called ERP for that 4337. Yes. So it's also an EIP in it. Yeah. And you can go check it out. Sorry. Yeah, so we have the code. Yeah, so it's also a thing for the builders to know, just to be able to always include like your dApp to be very friendly to people who don't understand a basic thing like what's a wallet or what's a token at the end of the day. Yeah, and as you can see, Jamit has done it quite well. Yeah, so it's we are in. As you can see, you don't have any XP. That means I've not listened to any of the music, and it also showcased that I don't have any coins under my wallet. So if I want to get any coins, then I get to buy them from here. Yeah, so as you can see, if we went to other sites, this would have been tokens, but since Jamit has embraced that methodology of ensuring that everyone who uses this site doesn't have a thinking that they're using a blockchain powered site. So that's why you can see all the coins are just listed in either dollars and yeah, coins, and you can see you can pay with Visa and everything, but PayPal, but also you can also pay with the LSK token through off ramp and on ramping. Yeah. So off ramp and I hope you are conversant with off ramp and on ramping. So this is like changing fiat to stable coins. or changing, because fiat is like dollars, the normal currencies that we use. But when you come to blockchain, it changes to become, you can either use stable coins or you can use tokens. So the changing from one currency or the fiat currency to the blockchain tokens or stable coins, that's what's called off ramping. Yeah, and no, on ramping, and then off ramping is the reverse. Yes.
Could you just precise for everyone what is on ramp and off ramp?
Okay. So one more time. Okay, let's actually use this page. So if you go here to your wallet, let me just use that. Just use the wallet of the day. And if you go to tokens, you'll find that we have it. And every blockchain network has their own tokens. Lisk has LSK, Ethereum has ETH, maybe Solana has Sol, and all those others. So imagine that you have dollars, or you have your own country currency. In Kenya, we have Kenyan shillings. I don't know in Mexico what's the currency there. I'm sorry, but yeah, imagine you wanted now to buy Ethereum. How would you go about it? So we have dApps that have been built to help people with buying these particular tokens. So when you transfer fiat money, which is the currency, let's say $1 to Ethereum, or you want to buy a certain amount of Ethereum and you just have dollars, that's what's called on ramping. Yeah. And then when you want now to withdraw your particular Ethereum to your dollar currency, that's what's called off ramping. So let's see, we can find one here. I think phone bank is an on ramp, off ramp, but I think it just only does for Kenyan shillings. Yeah, yeah. Okay. So we just use this widget, as you can see, because that's how just it looks. And as you can see here, they use M-Pesa because it's like the mobile money in Kenya. That's the most common and the most used. So if at all you want to buy a stable coin, USDT on the Lisk ecosystem, and you want 10 USDT in the Lisk ecosystem, it translates to 1,337 Kenyan shillings into Kenya. And with that, you just need to specify your wallet, and then you connect your MetaMask. Okay. Oh, I think there has a problem. So once you press get from MetaMask, it should show you like to go to MetaMask. Yeah. So I think they've added. So you can either use Naira, Ugandan shilling, South Africa, Ivory Coast, depending, and you can buy any USDT in the Lisk ecosystem. So this particular method is called on ramping. Yeah. So one USDT to let's say Ivory Coast currency, that's off ramping, and one Ivory Coast currency to LSK USDT LSK is on ramping. Okay. Yeah. So it's like send and withdraw, just the same terminologies that you use for banking ecosystems. So when you're sending, it's on ramping, but when you're withdrawing, it's off ramping. Yeah. Hope it's now clear. Okay. Yeah. So I was just speaking about the Jamit ecosystem, and I was telling you that you can see there's a front end side, but you don't see the back end side. If most of you are really conversant with how the website world is built, like you as a user, you just see the beauty of it, but in the behind scenes, it's a lot going on there. So in the behind scene, definitely there is a smart contract. In the behind scene, definitely there is a database, and all of this should be in the blockchain ecosystem. And how we do that, whereby you have a smart contract and you want to connect it to your frontend, you do this by using Web3 libraries. So there are different libraries that are used to connect your front end to your smart contract. So some of these Web3 libraries are like either .js, Web3.js, and VEM or VM, whatever how you want to pronounce it. So with either .js is a JavaScript library that allows developers to interact with EVM compatible blockchain networks, and you're also going to see how they do that as you move. On the Web3.js, it's also a JavaScript library that interacts with EVM networks. And the difference between either .js and Web3.js and VEM is a TypeScript interface for Ethereum that provides low-level stateless primitives for interacting with Ethereum. So all of this, just because I'm saying it's Ethereum, it doesn't mean that Lisp doesn't support this. As long as that chain is EVM compatible, they can be able to use these Web3 libraries either to communicate with the smart contracts that are deployed and also read the data that is in there on the smart contracts. A terminology that's used about to have the data in the smart contracts is on chain. So when you hear people saying I want to read data on chain, they do that using Web3 libraries. Or you hear them saying I've just deployed my smart contract and my smart contract is not showing. That's because the Web3 libraries are not really connecting with the smart contract side of the smart contracts at the front end. They are not really connecting quite well. Yeah. And if you want to go and check out and read more, just press the read more link and then it will take you to a lot of resources for ether.js and web3.js. Yeah. So you might be asking, why should I use ether.js, web3.js, and VM? That's a spelling error. And as I've just said, ether.js and web3.js, they're both JavaScript libraries. Ether.js can also support TypeScript, and VM is TypeScript based in terms of language. So as you can see, the amount of size that could occupy into your particular DApp is as it's seen, and I'm just going to concentrate on what it is best for and the key strengths for each and every one of it. So for ether.js, it's mostly used for modern apps. Apps like MetaMask and Tally, they do use ether.js for their interaction between frontend and their smart contracts. Web3.js, it's mostly used for full node access. So, for example, if you want to create a node and you want that node to communicate with the front end side, most people use Web3.js. So, it's mostly used for heavy backend workload. And VEM is used for high performance, and it's mostly used because people want to use it with TypeScript, and it's also used because it's also like WAGMI compatible. For ether.js, the difference between ether.js and web3.js is ether.js has a built-in wallet class, while for web3.js it doesn't have an inbuilt wallet class. For ether.js, it's lightweight, and they also have a very clean API, and it's very easy to use. So that's why most of the times when you're trying to build a dApp, you'll be mostly directed to ether.js because it's very easy to use. For web3.js, they are known for their legacy feature rich, and they also rely on external providers. While on ether.js, the providers might have been already integrated within the ether.js. Yeah. So lucky for today, we are going to concentrate on ether.js because I don't want to confuse you moving forward. I'd rather that you understand interacting with the blockchain with ether.js. And once we've all done that today, then maybe as we move on, maybe in the next lesson, we can try it out with web3.js or VM. But for today, we'll just concentrate on ether.js. Yeah. Okay. Yeah. So as I'd said before, either.js is a JavaScript library, and it has a few components whereby it has a provider, it has a signer, and it also has contract. So a provider is whereby you are able to connect to Ethereum nodes. So I'm sure you were taught about how the nodes interact to go and make a blockchain network. So some of the Ethereum nodes that either.js interact with is like JSON RPC. We have Infura and we also have Alchemy. So if you also want to go and try and see how Alchemy works also in Fura and also JSON RPC. I've also attached some links here and you can go check them out. Also, for the people who are website focused, you could try and say RPC works like HTTP, only that RPC is blockchain focused. Yeah, and it's also JSON based. Another core component of either.js is signers, and this represents the Ethereum accounts whereby you can sign and transaction and messages. So signers is the private key that you have in your wallet. So as we are trying, or as we go forward, you'll be seeing while you're trying to interact with any decentralized application that is built either on Ethereum or Lisk, you'll see that every time the wallet asks for confirmation or confirm to connect to this particular DApp or confirm for this transaction to happen. So that's the work of signers, and that is done by the private key of the particular wallet that you have that has a public address and a private key. So that's the work of a private key that you do have in your particular wallet. And as always, ADAP has a contract, and also the Ether.js has a component of contract whereby this particular contracts have ABIs, and they also have Ethereum addresses that are then used to connect to the front end side. So don't worry about the contracts. We are going to see how that works in an example that you're going to see on how it works uh, using contracts and either.js and getting that ABI and also getting an Ethereum address, which can also be called a contract address. Yeah, so use cases of the ether.js, as I said, some dApps like MetaMask and Tally, they do use ether.js. Either you've created that token by yourself or just the ecosystem token like ETH or LSK. It is also used in smart contract interaction, signing in and verifying messages. Yeah, now using the signers. Yeah, before we move on, we're trying to seeing how either.js works is first of all you'll understand that I want you to understand that you need to have a contract running already. You need to have written a contract already, and you need to also have connected to that ecosystem that you're trying to deploy your smart contract to. So I don't know if you covered this. I just put it here because it's like always the one step for you to be able to connect to that particular chain that you're building. So remember that if you're using Ethereum, it's quite different, not so much different. It's just like some RPC endpoints and the chain IDs differ. But for the Lisk ecosystem, I just want you to understand how you can do it, because even for even for some builders, every time I'm trying to tell them and send you some LSK, it's always like very hard for them to understand how to make their MetaMask called that LSK token. Okay. So how you do this is we have a link here in the Lisk docs whereby you can find everything. Sorry, whereby you can find everything on how to connect it. But for today, we'll just go very fast. Also, I'm sure that you know there's the mainnet side and the testnet side. So the testnet side is whereby you can play around however you want. it's not real. You can have, I could say, fake tokens. You can try to send them as much as you could, but on the mainnet, if you put any
Allô, allô?
you try to spend it, you'll find that
I think there is a couple of connection issues actually. Yeah. Pratique pas? Allô, allô? Ouh, ouh. Ah, 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 ah. So sorry. So just we will wait. Ah, ejected. I guess she's coming back. She's coming back. Yeah. Network issues. Yeah. Exactly.
talks
Ah, ah. Pratique
lost me. Yes.
Yeah, we lost you during the two last minutes. You were showcasing your MetaMask. If you want to share
Okay.
your screen.
Oh my god. So sorry. Uh-huh.
I see my face actually.
Okay. Okay. Can you see the screen?
Yeah, just my face. So you can switch
Oh, okay.
to
Let
another
me try sharing.
window.
Okay. That, can you see
Yeah,
anything?
good.
Okay. Okay. Hope you can see also my MetaMask wallet. Okay. Let's go back to that site. Okay, let me also put it on the chat so that we go together. Okay. Okay. So first, as I'd said, in your MetaMask wallet, while you're trying to search here for Lisk, it might not appear like mine is appearing. You might not find it. So how to do that? Because you have to add the Lisk network customally. You have to add a custom network, and as you can see here, on this docs, you can see there is a table that gives you the details of each and everything. So here you just write Lixipolia testnet, and also for the RPC too. So okay. So another thing is, when you try to move to this other side of the website, you lose that path that you had tried to run on in your MetaMask. So it's always advised to copy first the RPC, and then now you go and try to add that custom network, because the other ones are easier. You can just write them up. Yeah. So yeah, you should just write it. You input the chain ID, and then so for me it's saying it's already in use because I've already added my custom network, and we use it is our currency symbol. And for block explorer URL, you also input it just like that, and then you save, and then automatically now from there on you'll be able to see the Lisk Sipolia testnet. So if you want to do for the mainnet, it also has like a different RPC endpoint, and also a different chain ID. Yeah, so that's how you do it. Okay, so let's go back to our network, which is now we are in the Lisk Sipolia network, and you can see we have the Ethereum token, and we also need to have the LSK particular token. So how to do that? You just come here to import in LSK to MetaMask. So you can just follow that route. And for you to be able, sorry, I'm looking for something. So there's a table that you can be able to, yeah, this is it. Contracts. There's a table here on contracts whereby you can find all the tokens that you want to add on your particular Lisk MetaMask wallet. Yeah. So if you want to add any of the tokens here that are supported on Lisk, you just need to have the contract address, and yeah, that's how you add it. So let's try to add for Lisk, because on that particular account we didn't have the LSK token. So as you can see here, we only have Ethereum. So here you just press import token already made or created previously, and then select Lisk Poly Network, and then here whereby we copied the particular contract address, we input it there. So the contract address always starts with 0x so ensure like because when you copy it, it will just give you a link. So ensure it's only like a contract address. Yeah, yeah. And then sometimes the token symbol might be populated, and sometimes it might not. So if it's not, you just write the symbol which is already here, LSK, and you press next. And then as you can see, it's trying to ask you if you want to add Lisk, and then you say import. And then if we go back to our tokens, now you can see we have LSK and we have Ethereum. Yeah, so that's how you add a token to your MetaMask wallet. So in the Lisk ecosystem, we use Ethereum as our main token. And since you are in Sipolia testnet for it, however you want to do. I've already inputted the faucet links here. So you can just use the Lisk Sipolia faucet, or you can use the console, optimism faucet. Yeah. So just come here, you sign in.
Superchain is like where you can find all kinda all best layer to in the ecosystem. You can see as Unichain from Uniswap, Base, Ink, Lisk,
Yeah,
Optimism.
yeah.
Is
Definitely,
Lisk
that's
mainnet
the
already a layer 2 of Ethereum? Yeah, exactly.
yeah. We do have mainnet, and we also have testnet. So the reason why I'm showing you testnet is because you are builders, and most of the times you'd want to test out either the smart contracts that you're building, or you'd also want to understand how the particular tool is working before you move to mainnet. Because once you move to mainnet, everything that you do is live. Like, you can't backtrack on that. Oh, sorry. because they're using Privy. So for those of you who know Privy, they are a very secure wallet to log in the network. Yeah, so you just assign it in like any other
I oops again. That's okay. Mm, yeah. But I feel it's kinda like the reality in Africa in terms of network. So yeah,
Yeah, no worries. It can happen to anyone. Yeah. Can
yeah,
I have a question while we are waiting?
sure.
S- Just since you mentioned Superchain, I was wondering if there is actually like uh, single access to Superchain, or you kind of connect to that while you're connecting to your developer chain. Yeah. Can
No,
you?
in fact, like for example, on MetaMask, you have to add whole network or different networks on the
Yeah.
blockchain ecosystem. You don't have like one access to one
Yeah.
wallet itself, etc. Yeah, I know it's quite boring. it's it's a it's the issue with Ethereum. I feel it's like the only real issue is there's some network and sometimes you are super lost on which one to use, etc. But actually on MetaMask you have to really add whole RPC endpoint. So yeah, sorry.
No, no, that's all right. I'm just like from what I understood, like there is an ongoing like initiative to build up the super chain, right? Like the since they're all the layer two, they're kind of getting uh similar in terms of standards, yeah. Uh, or do I understand it correctly?
Sorry, what's the question
yeah.
for Pratibha?
Yeah.
Yeah.
So the question is, are they trying to make it easier so that you don't have to always like add an RPC every time you're trying to maybe connect to a network? Or what's the question? Sorry.
You know that you can
Exactly.
use, let me just send you chain list. Yes, you can use chain list. It's gonna be better. Like I mean, you just have to connect your wallet and let me share it on the chat. And you just have to connect your MetaMask wallet, and then like that you can automatically add the network. It's better, like otherwise you every time have to do it manually, so it's an issue.
Yeah. Okay. Yeah, if you just use chain list, it definitely becomes like a lot easier. But if you just use like manually trying to enter, you're definitely going to get some problems because you might miss like a link or something there in. Yeah, so where was I before I got lost a little bit? Oh, I was trying to show you on how you can be able to get some testnets LSK in your particular MetaMask. So you can use the Lisk Sepolia faucet, or you can use the Superchain Optimism faucet. For the Superchain one, you'll definitely need to sign in. For the Lisk Sepolia faucet, you don't need to sign in. So you just put your public address there, and as long as you are in the Lisk Sepolia network, you just input it and then you request, and then you can track your transaction using the transaction hash. But after some minutes, you will receive some zero point 0.1 LSK, yeah, per request. If you want some ETH, you can use the Superchain Optimism one, and you will get some testnets or there. Yeah. So if you don't get some through either the super chain and also the Lisk faucet, you can just let us know in the group, and then we'll see on how we can send some to you. Yeah. So now, since we know how to connect to the blockchain, we can now move on to the next thing, which is now we'll be interacting with the smart contract. Yeah. So as I said, you need to have a smart contract already built for you to be able to interact with a smart contract. So for this, you can either use Remix to deploy your smart contract, or you can just use Hardhat or Foundry. So how many of you like do know how to now deploy your smart contracts using Foundry, Hardhat, or Remix? Maybe let me get some reaction so that I know how to move forward from here.
Well, we did the Ethereum speedrun test, and we were able like to deploy to test deploying the smart contract on Hardhat. Yes.
Nice, nice, nice. So that's really great. And the difference between trying to deploy also on Lisk, it's just the network. So you're just going to do like a very fast deploying using a just NFT contract. So this NFT contract, you're just using the ERC721, and it's recording the current token ID, and you can be able to mint this particular NFT to a particular address, public address that is. So on the Remix side, if at all you've created your own contract, you just create a new file and then you input your name of the contract, and then you write your contract. So for me here, I leveraged on the Open Zeppelin library contracts, which they already have like the ERC 71 contracts, and here you just use or you import the ERC 721 contract instead of writing it from scratch. When you import it, your whole contract just reads from the Open Zeppelin contract. So here you just import, or on your terminal you can just write npm install Open Zeppelin slash contracts, and then it will install that particular library for you. So as always, you have to compile your contract first. And here in the Remix side, you can see it's compiling. And once it's compiling, and if it compiles with no errors, it means your contract is good. It's good to go, and you can be able to deploy it. And yeah, so as it's compiling, anyone who understands maybe this particular contract and can say about something that they've not maybe come across, like maybe the use of safe means. Don't know what a safe means is. As we wait for it to compile. Oh, nice. So, Celine. Then we do hard hat, and we try like we try to deploy from Remix, and then I think Foundry it will be homework for you because we also running on time here. Yeah. Okay, let's go back to our contract and see if it's just compiled. Okay. So for those who don't know how Remix is done, is here is whereby you see all the results, and yeah. So always also for the smart contracts, always keep keep in check with your version, because it's also going to be used in the deploying side. So that's the, I think most people find Remix easy because you just press some buttons. You don't need to write commands, and it just goes like smooth. So for this, we are going to use, remember the MetaMask that we connected, the Lisk network, and we also tried to get some test nets on it. We are going to try to deploy using that. And for this, you're going to use the injector provider environment. Okay. Yeah, and when you press the injector provider MetaMask, it's going to give you a pop-up of the MetaMask, and then it's going to ask you to connect your particular MetaMask. So let's see if maybe we try to add an account or we edit. Okay. Yeah, so if for me, I've already like connected that particular account. So let's maybe I try to disconnect it, and then you try to see if at all you can connect it again. So let me go back to the wallet that has some testnet. It, as you can see, for me, I have this is not real money; it's just some testnet it that you're going to use to be able. So as you can see, if you press here, you can see the particular site that you're connected to, and you can disconnect it. So if we disconnect it, you'll see that definitely we don't have any account here. And
Hello, hello. Could you hear? On the screen? All good?
okay,
Okay.
hope my screen is visible. Okay.
Yeah,
Yeah,
yeah.
you should see a pop-up of MetaMask here. Or if you just press your MetaMask, it should give you like a pop-up of trying to confirm for you to connect with that particular MetaMask account wallet. Yes, as you can see, it's loading. I think I'm having issues with my network today, really. Okay. Just give me a few. Okay, so we are back. So as you've seen, I've just pressed the injector provider MetaMask, and then we get a pop-up of the MetaMask, and it shows if you're trying. It asks you to connect to that to Remix this site that you're using, and then when you connect, it's now connected, and you can see your public address on it. So okay, we have to compile first contract. So I think we can come back to this. We try first the hard hat, and then we come back to this because after the network has become good. So with hard hat, so you can see my screen. Let me zoom in. Okay. So with hard hat, how you do it is you first create the folder that you want your contract to be in. So for me, I just named it List Summer Bootcamp, and then you change the directory to be in that particular project. And then after that, you create. So this is me just trying to line up my project nicely. So I called the project Interact Blockchain, and then I moved to that directory, and then use the npm init dash yy to create a local node in your machine. After that, for it to be accepted, then you will see the package.json, which is this that has its name, version, and then scripts, and then the author and the license. After that, then you install Hard Hat into your particular project using the npm install dash dash save dev Hard Hat. So for those who might be feeling I'm rushing towards it, don't worry. I'll also input all the um, commands for you to run them by yourself. And then after that, yeah, after you've installed the hard hat, it will have installed. So you get the response of the package that has been installed. And then after that, now you write the command npx hard hat for you to be able now to create your particular project. So as you run the npx hard hat, it's going to ask you some questions like the particular project that you do want. So for myself, I went with TypeScript. There's other options like a JavaScript project. So I went with TypeScript, and then it asks you the project route. Where do you want your project to be situated in? Then for me, that was the Interact blockchain that I'd created. And then it asks if you want the .gitignore file, and this is mostly used to hide either your API keys or those huge files that you don't want them to be pushed to GitHub, and that which might take some time for you to push a particular project to GitHub. So if you have any secret keys, API keys, you input that particular file on .ignore, and that's the same reason why I answered with yes. And then it asks you to install the Nomic Foundation Hard Hat toolbox. So this is a library for Hard Hat, and then you say yes, and after that you'll be good to go, and your project should be created. And if your project is created, so for this, if your product is created, you can be able now to see all of this in your VS Code. So you can open your particular code using VS Code using the command code and then space dot, or you can just open VS Code and then just open manually your project. So it has artifacts, cache, and contracts. So this is where you have your contracts, and then it has the node modules and your scripts. This is whereby you find how to the configurations on how to deploy your contract. It has a test folder whereby you have all your test files for your particular smart contract to be able to know if it's running as it should. And then it has .env. So this is whereby you package JSON, and package JSON is whereby you find all your dependencies. Then read me if you want to explain what your project is all about. So it's the same contract I've used on Remix. The difference is just the tool that you're using to deploy and also build the smart contracts with. So it's just the same NFT contract whereby you can be able to meet that particular NFT to a recipient who has a public address, and every time there's a mint, it creates a new NFT with also a different name and a symbol for that NFT, which is NFT. We also have a test case for that particular contract, whereby here you can see you're using a library called Chai. And here you can also see we are trying now to use ethers here, whereby we are trying to see that to it that the particular name that we do have for our NFT is also the same that you're trying to do with that particular NFT. The test cases, as you can see, a signer to be able to mint NFT. Remember when we said signers are used to confirm that a particular either transaction, you can verify either a transaction is happening, or you can verify either an action that's happening on the smart contract should be able to happen and in that particular sequence. So for this test case, it's looking for that owner who is a signer who has a public address and also has a private key to be able to allow that particular um, owner or public address to mint that particular NFT. And it's also going to check out if also that particular owner has some ETH, which is the gas fees to be able to mint that particular NFT. Yeah, I think that's it. And also on the deploy side, whereby we have a script file for deploying, it's also going. We have configurations here using also ethers to be able to deploy that particular contract, which our contract is called NFT and nft.sol, and it's also going to catch some errors if at all that particular deploying of that contract won't be possible. So coming back here, as you can see, if you're using .env here, which here we've saved our private key, because remember, as we're trying to do on Remix, you will need your MetaMask wallet to be able to deploy that particular contract to the Lisk ecosystem. So on the .env, you just input your private key. So don't worry about mine. I'm going to, change that wallet, and I'm just showing you so that you know how to go about it. Also on the .ignore, told you here where you hide all your API keys. That's why we have the .env here, and for you to be able to know if your test case is working, you have a command called npx hard test. So if you run
Oops. Um, coming back. Tuk tuk tuk. By the way, in 5 minutes, you can class attendance checking.
okay, we good. Okay, so you have to hope you're good, didn't get lost.
Um, for the moment, we can't see your screen.
Okay.
Yes.
Okay, can you
It's
see my
my face.
screen now?
So yeah. Mm, all good.
Okay, okay. So as you can see here on a particular contract to this particular network. So how you do that is by having the configurations here in hardhat.config.ts. So here we have the particular same version that we here we specify our LISC Sipolia testnet first with the RPC endpoint that we also use to connect a mask wallet, and we also specify the particular um, wallet that you're going to deploy our contract with by referencing it using the private key that we've been put our .env, and then yes. So let me. Okay. So if you want to depend in your network is yeah, and then network is already listed as part of the network for you to be able to deploy. You can just run this command npx verify list networks, and then you'll see all the commands that are there. Yeah, so those are that's for verifying. And once your contract has been able to been deployed, you'll get a contract address, and that same contract address is the one that you will use here in the block scout. The block scout let's see, what is it called? So in Ethereum, we have Etherscan, whereby you can see all the contracts that have been deployed, and you can also interact with your particular contract. But in Lisk, we use Block Scout. So we have a Block Scout for testnet, and we have a Block Scout for mainnet. Yeah. So if you deploy a particular contract, it's going to give you a contract address, and you can just copy your contract address here manually, or you can just press the link that's on your terminal after you've deployed, and then you'll get this particular page showing you all the details. So here we have now the contract. Okay. From there on, I think we didn't do for remix. So let's see if it's okay to compile right now. Okay. I think it has. I have some network issues problem, but as long as you've provided the injector provider MetaMask here, and it has connected with your wallet, should be already in the Lisk Epolia testnet. So if at all you've chosen the injector provider MetaMask, and you have connected Remix with your MetaMask wallet, you'll be good to go by just been able to deploy from this side in Remix. Okay. So once you've deployed your contract, the tests are doing well. You've deployed your contract. It's already on the Lisk block scout. You can see your contract has already been deployed. The next thing is for you now to verify your particular contract. So how do you do that? So you can verify your contract using Remix or Hard Hat. And because today we are so unlucky, we'll just do with Hard Hat. And from there on, we can move on. So as you check out here on the side of our contract, you can see we have details and contracts. So if you move to the tab of contract, you can see we have the code, and we have the read and write contract. So here you can see the contract name, you can see the EVM version, you can see when it was verified, you can see the compiler version, and you can see the contract file path, which is the same as in your VS Code. So as you can see, this is our contract, and if you also check out with other dApps and you get their contract address, you can be able to see some of their contracts here. Yeah, so we have the ABI. I'm going to speak about it right that later. So let's try and verify and publish this smart contract. So when you're trying to verify and publish your smart contract, you have to choose your license. So for me, if you check out in my nft.sol, I'm using the MIT license. So for that, the same reason, I'm going to use the MIT license. And if you're using Remix, you'll use the Solidity single file. But if you're using Hard Hat, you'll use the Solidity Hard Hat. And then it's going to give you your Solidity Hard Hat plugin. And then this, hope you can see my screen. Okay, good. So this hard hat config is what you put in your hard hat config in your VS Code. So as you can see here, we have the Etherscan, we have the Etherscan API key, we have the custom chain, which is the network, the Lisk spoiler with the chain ID, and the URLs, which we have the API URL and the browser URL. So the key thing here is for RPC endpoint to be perfect, and also for your Etherscan API key to also be perfect. Although this is not quite significant, but it's also good for you to have your Etherscan API key available there. So how you can be able to get your Etherscan API key is you use the Etherscan website, and once you log in, you go to your API dashboard. You can be able to find your API keys, and you can either create an API key or use an existing one. So for me, I created the one with the Lisk spoiler, and you copy your API key, and that's what you use here in your hard hat config. So as you check out here in the list block scout, so it has also given you a command for you to be able to verify your smart contract. So this same command is what you will use here on your command or terminal to be able to verify your particular contract. So you use npx hard hat verify network, then the network is definitely Lisk testnet, and then these 0x keywords, they are your contract address that you got when you deployed your contract. Okay, so because you're verifying your contract, you definitely have to have your contract address there. And as you can see, once it has verified, it will show you that your contract with your contract address has been verified. And if you're trying to verify partially, use force, wherever. So if you want to check out the particular verified contract, you can just find it here on the block scout. And this also shows how transparent the blockchain ecosystem works, because you see everything real time and also how it happens. Yeah. So once you've also verified your contract, you will also be able to see your ABI. So every time you deploy your smart contracts, you're able to see your ABI. So this is a JSON file with all the information of your smart contracts, and this ABI is mostly used to connect now your smart contract to your front end, and you're just going to see it now how it's happening. So for those who are also following on the slides, don't feel left out. So I'm just moving on to how to read data from your smart contract, because right now I've been able to interact with our smart contracts by being able to deploy it, and we've also been able to see how that smart contract being deployed moves to the block scout scan, and we've also seen how ethers is used even in that part of deploying. So how you are able to connect your front end. So I think Vikesh also handled that bit of you being able to create um, your React project. Okay, so for me here, I created the same React project. So you use the npx React app command to create your React project, and then just as any other React app, it has the app.js, has index.js, has your CSS. If you're using the plain old CSS, you can also include Tailwind or any other framework that you're using, Chakra UI, Material UI, to make your site look very beautiful. And then where we have now the connection between the front end and the smart contracts is the use of the ABI. So once you deploy your smart contract here under your Block Scout, you'll be able to see your contract ABI. So for every person who's going to deploy their contract, they'll have a different ABI. So just copy that particular ABI and transfer it to your front end. Create a file called your project. For me, I created my NFT ABI.json because it's a JSON file. So you might, when you're trying to copy it, it might not be coming aligned as a JSON file. So you just format the document and then you use the JSON formatter for it to look this pretty clean. Yeah. And then so I just created like a small website for you to be able to see how you can mint that NFT. It's not beautiful. I understand last week you tried to do something beautiful with React, but for this I am just trying to show you how data can be read from a smart contract, which is the Lisk ecosystem, and it affecting the front end in real time. So here we just have my component, which is the NFT. And then here now we um, use ethers to be able now to connect your smart contract with your front end. So for you to be able to do that, you have to, in your particular project, you have to install ethers by doing npm install ethers. So hopefully my screen is still up. Yeah, very good. Any questions? Yeah, so also the class attendance is up. So ensure you go to Google Classroom and check your present attendance to today's class. Yeah. So if you want to install ethers, you just, as any other React installation, you just use the command npm install ethers, and it will install ethers in your particular front end app. Another thing to also be keen, take note, is to note your contract address. Just as the same way you use the contract address to verify your contract, that same contract address is used to also let know the front end app of your particular smart contract. So that's why here we have we've been able to initialize our contract address, and we've input the contract address that you're using. So in Ethers, we've also communicated of the fact that we need a provider, and that's the reason why you've also seen us making this hook of a provider and a set provider. And here it's where you see we are able to connect the provider to the signer. So every time you go to a site, as you've seen with Jamit and also PhoneBank and also any other app, you'll be able to connect a wallet. And for you to be able to do that, this is how you do it, whereby if someone gets into your app, they are able to either automatically be forced to connect their wallet, or they can just do by their own by connecting their wallet, or using the account abstraction method, whereby they just input their social login or their Gmail and their phone number, and then they are created a wallet address for that, because that will be used now to transact or to also, in our case here, mint an NFT. Yeah. So As you can see, the hooks that we did use, so this is for this, it is showcasing when you go to that site, you will be already prompted to connect your particular MetaMask wallet. So as you can see, you get the user address, who is the signer provided by the ethers.js, and then you create a contract instance whereby you declare your particular contract with the contract address, the ABI that you removed from Block Scout, and your signer, and that particular way now you can be able to load the contract data. If at all you can't be able to load the contract data, you have a try and catch case there, and then it will showcase you an error. If not so, if you've not connected your MetaMask, then you also have an alert there showcasing you to connect MetaMask. Also, you have a function for loading the contract data, whereby at this point we have the contract done by the contract address and the address who is the signer. And here now you can see we've done some functions whereby you can be able to see the token ID, and you can also be able to get the user NFTs, which is pulled down from the contract side. So let me show you how it looks on the side of Block Scout, whereby you can be able to interact with that particular contract even without having a front end. And this is how it looks. So here on contract, you can see we have read or write contract tab. And here you can see all the functions that you've input in your smart contract. For example, or as you can see the balance off. So this one showcases you the balance of your particular MetaMask. How much balance do you have, and can that be able to be used to mint a particular NFT? So you can just play around by that. So also take note, we have read and we have write functions. Read functions, they are used just to read data from the smart contract. Write functions, they are used to add data or input data into your contract. So for that, you just read, and then if you reset, you can just see the particular balance that you do have. Okay, if that particular also address, so here we've connected my particular MetaMask address. So if you can be able to see the current token ID that I have, and let's use a write function whereby you can see a particular, let's use a different public address whereby they can showcase on how to mint. So let's use this. It, but I'm just going to write it automatically so that it just goes to the contract. And as you can see, I've tried to write to mint and write through the contract, and as always, as the signer, I'm supposed to approve that particular transaction that I'm currently doing for minting. So it's also going to take some gas fees, and once you confirm, you're going, that particular public address or owner is going to mint that particular transaction, and then once it's minted, you can view that transaction detail just on the Block Scout, or you can just click that link and then see. So if we go back here and we try to see the current ID, we'll see that some of the NFT has changed from one to, we have two token IDs, and it was one previously. So meaning we've been able to write into that specific smart contract. So how does that look on the side of front end? So using this front end that I had written, you will see how it looks. It just looks so simple. So yeah, that's how it looks. So I just call the site my contract interface, contract info, and then I have the current token ID. So if I reload it, it should push me, or if I run my local host again, it should push me to connect my MetaMask wallet. Okay, So this is it. So as we move on, we will see other ways on how we can be able to connect our MetaMask wallets by using things like Rainbow Wallet and others. So this is just like a scratch way of how we are going to do it. But on the next Thursday lecture, we will do like a comprehensive way of how you can be able to ensure that people can be able to connect your wallet and how to use other frameworks or other libraries to be able to make it very smooth. Mask wallet, which it's the same as our block scout, whereby you can see the current token IDs are two, and also on the front end side they are two. So let's try writing into a smart contract using our front end so that this data goes to our contract. So we'll just use a different public address and try to mint this particular NFT so that we see if at all the token ID will change. So minting an NFT, and then you will see again the MetaMask asks the signer to approve of this particular transaction. And then once it does that, you confirm, and then yeah, it will have minted that particular NFT. So as you can see, yeah, and then after it has minted, it will showcase us an alert of mint successful. And then just in real time, you've seen that our current token ID has increased from 2 to 3. Yeah, and that's how you use ether.js to read data and to also change data into your smart contract using ether.js. Any questions? So I'll also upload this code um, to be able so that you can be able to follow. Yes, Yulia, you have your hand up.
Yeah. Well, thank you. First of all, I was really handy. Yeah. So basically, we can keep working on our existing React project, right? Like we just need to add my NFT JSON file, and that's it.
Yes, yes. Yes,
Okay.
yes. As long as you have your contract deployed on that particular chain, which for this case is Lisk ecosystem, and you can be able to get your ABI and you can be able to verify your contract, you just connect it to the React project that you did last week, and it's just that simple. Yeah, and also
Yeah, but
you're going to do yes, yes. Go on.
sorry. Yeah, but we would need like also to adjust interface, right? Because like it was, or we can maybe create a new project, like duplicating it, like in order to, I'm not a developer. I don't know what is the best practice for this. Yeah.
Um, I don't think you need to create a new project. All you need is maybe to update your functions. For example, have an init function here whereby in a React app currently right now that doesn't have blockchain is you will have either your um, JWT token or you will have your Google signing in. So in that particular function, now you replace it with the function of having that MetaMask pop up or having that connection of a wallet function. So you don't really need to do everything once afresh again. You just need to be able to call up using this function of
Okay.
call
Yeah, I
up
see.
data. If you have a, let's say, a function in your contract, yeah, yeah. So try and divide this. So it will all depend on your particular contract on how it's it's managed. So for example, in our contract here we have a function called mint. Okay, so in your front end it just might just be an art and maybe buy. Okay, so that particular function that you do have for buy, which might be here, mint nft, might be like buy, you have an on-click function called mint NFT, which is like now buying that NFT. And then here up upon this contract that you've done. And then you also call up upon the recipient address that you've received from this other function up here when you connected your MetaMask wallet. And when it returns, you just use the normal try catch for the user to see like it's minting, have a status it's minting, and then once it's awaiting, you now connect your public address to mint that particular NFT. And then after it has done successfully, which is loading this contract into your front end, then the successful of minting that particular NFT is okay or is good. If it's not, then it fails. Yeah, so the first thing I'd say is at least have the ethers functioning, and then have the MetaMask connected in your browser using the signer and the provider. So here you can see we have the browser provider who set that provider. So if the signer is already successful here,
Oops. Let me check the class attendance. Um, I don't know. Tuk, 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 tuk. Search for people. Yeah. Um, all good. All right, all right. Tuk, 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 tuk. Mm.
see where you're
Hello, hello.
confused at, and
We can't hear you properly.
then we can help you. And
Hello,
sorry,
hello, hello.
hear me right now?
Yeah, Kinda.
Can you hear me right now?
Yeah,
Hello,
yeah, but like,
kinda. Okay.
yeah, in the indeed.
Okay. So where did I leave you?
Like you were talking 3 minutes ago, maybe? Allô, allô? Allô?
Yeah.
We can see
Can you
your
hear me?
screen yet? Ah, yeah, we can see it right now.
Can you?
Do you want us to cut the
Okay.
camera, maybe? I don't know.
Okay. I've seen Yulia saying, Dusky saying she's confused. Uh, Particularly where, so that I can explain it more clearly.
Someone has a question? Celiana, yeah.
Yeah, can you hear me?
Yes, I don't know if
Yes.
So we have to.
okay. All
Hello.
good.
Okay, good. Yeah, I was
Yes.
just to clarify the confusion for Bratipa. I don't know if Bratipa can hear me though.
Yes, yes, I can hear you.
Yeah, I think a few of us are just wondering how the minting will work with our last assignment, because the last assignment we made a website that showed desserts and people could order desserts and it just needed to be a shopping cart, basically. So I think we don't know how it connects to the last assignment. That's the confusion.
Okay, okay. So for first of all, if you have a site that's buying something, okay, it means first of all, let me just showcase to you something like a rarible so that we get to understand each other. Okay. So this looks like maybe that site that you've built, and this is just the front end side. Remove for your mind that we do have a contract or anything. This is just a front end side that is clearly just built with React. Okay, so as you can see here, each and every NFT you can buy. Okay, so for this particular site, for me to be able to identify that particular user through the website, they have to connect a wallet. The reason why they are connecting a wallet is with blockchain. For any user to be identified, you have to have a public address and a private key. So on the side of the front end, this is how it looks. It's bare. It doesn't have any buttons that are reading data from any, I'd say, a database. But then every time you press this connect wallet, it pulls up this particular list of wallets, and you press MetaMask, and then once you press the MetaMask, it's going to ask you to sign in. Okay, and when you're trying now to confirm this, it so with your okay, I think there's something that's missing connected. I think it's because it doesn't have it.
Probably we're gonna just turn off our camera. I don't know. Probably it's gonna be better.
Okay.
Hey, we just turn off all our camera to make sure it's gonna be better. Yeah.
Okay. Okay. So, maybe one of you can send your GitHub profile for the particular assignment, and then it will be easy for me to like demonstrate. Yeah. But as let me share my screen. As I was saying, as you're building your front end, understand that first of all, your contract should be depicting your front end, meaning that if at all in your front end you have a product and that product is maybe supposed to be bought, it means that in your contract you should be having that function of buying. If at all your front end is supposed to be sending money from one person to another, understand that your contract should have a function of sending transaction from one point to another. Okay, that particular product is then depicted in your contract using a struct. So this particular struct maybe has the name of the product, it has maybe the price of the product, and then the token or the ID of that product. It will then be the ID of that particular product in your smart contract. So for the similar case is this site of Rarible that I was trying to show you. If it was just a Web2 site, it will just have buy now and whatever. But in terms of blockchain, they call it mint. Instead of buying, it's just phrased off with a new word called mint. So for the products that you do have, it should have mint. And for example, for this NFT, the smart contract will look like this, whereby it has a function of minting, whereby you can just call it buy, but because it's the blockchain terminals, it just has a mint, whereby it has a new item ID, which is now the NFT ID. And every time that NFT is minted, you increase the token ID of that NFT. And then it's you use this word of safe mint to ensure that the user is able to transfer that particular mint safely to the new public address that is minting that particular NFT. And then now you return the new item ID, that this new item ID you use in your front end to be seen as the current token ID. So that's how it functions. So in your projects for React for last week, first of all, this is how it looks. Okay. So we have a contract info, the token ID, and the address. And then if at all there's any user address, it's coming from the contract. Just the same way as you read your particular datas from either MongoDB or I don't know, or any other database, MySQL. It's the same way you are reading your data from your contract. So if you deploy your contract, it already has the data. As you see here in the read and write contract, it's just the same way when you go to Firebase and you've tried to deploy your particular product to the Firebase, and it shows you that you have some of the functions that you can either read from the Firebase cloud-based service, and some of them that you just read, that you cannot manipulate that particular function. So when you after you've deployed your contract, the current token ID, if for example this is read, it means in your front end side, you will just create a hook to store that particular state of that current token ID. And then this particular current token ID in your front end side, it's what's going to be consumed here in your paragraph, whereby the current ID is the current token ID. How is it manipulated? Every time you're trying to it tries to reload your site, it runs this function of load contract data, whereby it reads the token ID of that contract. Now here it reads this current token ID, and through ethers, because whatever is connecting this side and this side, it's ethers, the Web3 library, and then using the contract, okay, dot current token ID. Imagine it as if the way you use Axios and you're trying to call on a product, and that particular product has a JSON file of product, and inside it has fields like product.name, product.id. So it's just the same thing as here, whereby the contract has you the current contract that has the JSON file, which is the ABI a JSON file. It reads now contract dot current token ID, which is removed from the contract. Okay, is that a little bit clearer for? I'm forgetting your name, Sule. How can you retrieve the token ID or let's say I need to store the token ID minted. Oh, okay. I think what Marcelo is trying to ask is something called the big save, or the how the contract do save the IDs, and how you can now reverse. Also, that we are going to discuss on Thursday on how you can use the big int. I'd say how the contracts are built in smart contracts. To mint in this case is transfer ownership and the token ID. Yes, Celiana, you've really gotten that very well, because when I've minted notes before, I had to upload images onto IPFS. Yes, so so minting is to transfer ownership, and then the transferring of that ownership is tracked by the token ID. So other when the product when this project grows to now become a bigger project, then every time that particular token ID or the NFT is now, it can be pushed to IPFS now using also Pinata. Yeah, but this was supposed to be like the most simplest way of how you can mint or transfer ownership of that particular NFT from one address to another. Yeah. Any more question on that? I'll also include like other projects whereby you can be able to check out on how you can do that. We have this. I didn't finish up on that, but I'll share with you other projects like for voting up on how it can be able to, you see on the contract of how you can be able to vote, and it calculates the votes as it moves on. But for this, I just like created basic way of minting an NFT. NFT IPFS images. How does it work? Okay. Then I'll for Duxi, for that I'll have, because I didn't prepare today, I'll have to, because I now have to set the IPFS and the pinata file. So for that, maybe just to, so that we can deal with it on Thursday. Um Everyone who's here, they can just go and create an account here on Pinata. and then I'll show you on how you can push your particular NFTs names to IPFS and also Pinata. Yeah, but maybe we can see with this. Maybe check out. Maybe we can try and see this contract, because when I created it, we used Pinata. So you review on the Block Scout. So as I'd said, all dApps, you can find all their smart contract codes on Block Scout. You can also see all the transactions that have happened there. So let's check out this and see how it works. Okay. Okay. So this is the smart contract of this site that you're trying to look into. And as you can see, so for them they used what is it called? They used ERC 1155 instead of ERC 721. And yeah, so they've not verified or published their code, so it means you can't see the contract. But as you can see here, the functions that they do have, the read and the write functions, we have the add minter function, we have balance of reading function. You also have the ban, whereby if at all at any point they wanted to ban some of the NFTs, they could use that by banning the particular token. You could also meet and transfer a particular NFT. You could also get to know the creators of that particular NFT, and you could also get to know the royalty percentage of the amount that for this company was called Kiboko DAO, how much they were getting for each and every NFT. You could also renounce ownership of a particular NFT, and you could also transfer ownership. For example, if you did have an NFT and you wanted to transfer it to another person, you could be able to do that by placing a bid with definitely your price. Yeah. And we also have other functions like safe transfer from and to. Yeah, so this is how you can see. I wish we could be able to see the code, but they didn't verify and publish the code. And yeah, I don't have the rights. But you can see the inventory of the NFTs. So this all of the NFTs have been stored in IPFS. Yes. Okay. I think we are done. Let's finish up on that, and let's finish up on scaffold list, because it's almost time and I don't want to keep you waiting. So we've spoken about trying to do front end and contracts on different sides, and with scaffold list you can do all this in one side under one roof, whereby you don't have to have the need of installing hard hat, you don't have the need to create a React app, and all of this can be able to be done here. So ensure you have like hard hat, you have your node version is 18.7. If you're using yarn, use version 1 or 2. And I think I'll leave this to you, because we don't have so much time left, because I leave it to you to go follow this particular GitHub repository. Try to, yeah, try to, where is it? Sorry. Okay, found it. Try to run this particular scaffold Lisk. It's the same as scaffold ETH, but this is just for the Lisk ecosystem. As you can see here, you have the side for contracts, and you also have the side for front end. Okay, so they're using Next.js for front end, and for contracts they're using hard hat. So it's just the same way. If you want to deploy it also, we have a yarn deploy function there, npm run deploy, and you have a contract here. So try and go and deploy some of these contracts, like buy me a coffee, your contract.sol, and also try and go and run this particular front end and see how it looks. And then the next time you're going to meet in Thursday, we will have a very comprehensive manipulation of the front end side on how it looks. So I don't know if I have time. Maybe we can just, okay, we can try and run it. So, okay, we can try and run it and to see how the front end and the contract side are doing. So also Ethers is used to connect the contract side to the front end side. So this might be like a very good use case, or it will be a very good example for your particular project that you're trying to connect them to the front end side. So go check up on it, try to understand the function that they are using, try to see how the hooks are being used here, and then also try to use how to see how they've used rainbow kit to connect to use the case of connecting a wallet. And then in the next time we are going to be able to show you how you can be using this particular scaffold list in your day-to-day website. So the front end, this is how it looks, but all of this is controlled with the contract that has been deployed there. So let's just try and run and start so that you see how it looks. Okay, yeah, and chain, I have to make a local node of this. Okay, okay, we've not installed here, and that's going to take some time. Okay, I think I have to install this cmd time, and it's going to take some time, and I don't want to keep you waiting.
There's an interesting question about if we can use Skype and integrate our frontend with that template. So the answer is yes. Like, in fact, during hackathon, it's what we are doing every time. Is like just using scaffold it, or in this case, scaffold disk, and then just like replacing stuff, like removing everything and replacing stuff with the right front end.
Yeah. So all of those that have taken you through this and trying to read, I was trying to show you how you can do it like from scratch. But using scaffold list, this is like the most efficient way. Like you could spin up your contracts and your your front ends all at the same time, and it's very 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 fast. So all you need is just clone it, do yarn install, and then create your local network or your local node using yarn chain, and then yarn deploy to deploy the smart contracts, and then yarn start to run your front end, and then you'll have your local host running, and then you can play up about changing the front end on how much or however you want to do. Yeah, so that is homework to you. And next time we are going to see on how we can do this using something difficult like a voting DAP using the scaffold list. Yeah, so I think yes. So once you deploy your contract, the ABI is automatically generated in your Lisk block scout. So as long as you've been able to deploy your particular smart contract, the ABI will be just on the block scout waiting for you to copy it. Yeah, so you just keep note of this tab. So you just press the ABI and then it will have been already generated. Yeah. Any question?
Probably you can just talk quickly, like 1 minute, what's next on Thursday. Like for example, like we will go more deeper on the IBI side, etc., etc.
Yeah. So on Thursday we'll go deeper on first ensuring that the sign and the providers are doing okay. The transactions are also being, you can be able to transact or send let's say a token from one person to another. We'll also go deep all of this. So because I've done on Hard Hat and Remix today, we'll be using Scaffold Lisk moving forward, because the main key thing is for you to understand how Ethers comes in between the front end and the contract. Also, it will go deeper, whereby your contract will be having so many functions. We'll also undergo the error validation or error handling in both the front end side and the contract side, to be able to ensure that all errors are being catered for. Yeah, but that's going to be a little bit rough. It's going to be a little bit deep. So if today was a little bit fast for you, please ensure you like go over through the slides and also the code, and try to do some of the commands by yourself, so that on Thursday it will be easier for you. Apart from that, keep up the questions in the Telegram group, because I'll be there. I'll be checking them out, and in case if you want any code or any code snippets, I'll also drop them there, and also in the Google Classroom.
All right. Thanks a lot, and be sure to be there on Thursday because it's gonna be the most important session. And especially if you are following super well the next session, you will be like ready for hackathon. So make sure to be there, and you're gonna learn a lot of things. Yeah. All right. Thanks again, Pratibha. And yeah, see you on Thursday. Quite exciting with what's coming up. And yeah, all good. Tschüss, as we can say. Yeah, bye bye.